Hello everyone, I'm Mr. Furlong, and today we're going to practice balancing chemical equations. Now you may recall from our previous video that there is a law of science called the conservation of mass, which basically says that matter cannot be created or destroyed. And we always have to follow this law. And the example that we gave was that if we took mercury 2 oxide and broke it down into oxygen and mercury, the amount of mercury 2 oxide that we have at the beginning of the reaction has to be equal to the amount of oxygen and mercury we have at the end of the reaction. And when we write chemical reactions, we have to show that this is true. And so that's what we're going to be practicing today is how do we balance chemical equations. So I'm going to switch over to my other camera. And so what I've done is I've taken this formula of mercury oxide, breaking down into mercury and oxygen, and I'm showing all of the different atoms that we have. So mercury oxide is just Hg and an O, breaks down into mercury and oxygen gas, which is O2. So I'm showing two atoms of oxygen here. Now I have to make sure that the number of mercury atoms on one side of the yield sign or the arrow is the same as that on the other. Same is true for my oxygens. So when I look at this, I see that I have one mercury, so that's good. I have one oxygen, but I have two oxygens over here. I need to get a second oxygen on this side, but I can only add mercury oxide. That's what the formula says. So now I have two oxygens on this side, two oxygens on this side, but I have two mercuries here and only one here. So I need to add a mercury. And now I have two mercuries on the reactant side, two mercuries on the product side. I have two oxygens on the reactant side, two oxygens on the product side. I know that this is a balanced equation, and so now I would write this as 2 HGO yields 2 Hg plus O2. So in this reaction, I have magnesium plus oxygen yields magnesium oxide. I have one magnesium on one side of the yield sign, one magnesium on the other. Two oxygens, only one, which means I'm going to have to add another magnesium oxide to this side. Now I have two oxygens, two magnesiums, only one magnesium, so I'm going to add another magnesium, and now I have the same number of atoms on either side of the arrow sign, and so I would write this down as 2 magnesiums plus O2 yields 2 magnesium oxides. Our next equation, we have barium sulfate plus carbon yields barium sulfide and carbon monoxide. So let's take a look at this. An easy way to balance these is we always want to start with the metal. So barium, we have one barium, one barium. We have one sulfur, one sulfur. We have one carbon, but we have 1, 2, 3, 4 oxygens because it's an SO4, and only one oxygen here. So that means we're going to have to add 3 more oxygens. Now I have 4 oxygens on this side, 4 oxygens on this side. But now I have 1, 2, 3, 4 carbons on this side and only one here. So I need to add 3 more carbons. Now I have 4 carbons, 4 carbons, 4 oxygens, 1 sulfur, 1 barium, and my formula is BaSO4 plus 4C yields BaS plus 4 carbon monoxides. Let's look at another one. Lithium plus water yields lithium hydroxide and hydrogen. So let's start with the metals. 1 lithium, 1 lithium. 1 oxygen, 1 oxygen. 2 hydrogens, 1, 2, 3 hydrogens, which means we're going to have to add some more hydrogens. Now I have 1, 2, 3, 4 hydrogens, and 1, 2, only 3 hydrogens here. So I need to add another hydrogen, And I can do that by adding a lithium oxide. So now I have 1, 2, 3, 4 hydrogens, 1, 2, 3, 4 hydrogens, 1, 2 oxygens, 1, 2 oxygens, 1 lithium, 2 lithiums. Add another lithium. Now I have 2 lithiums. So now my equation is balanced. So I have 2 Li plus 2 H2O yields 2 LiOH plus H2. The next equation, we have iron plus oxygen yields iron oxide. Let's start with the metals. We have 1 iron, 2 oxygens, 1 oxygen, which means I'm going to have to add another oxygen to make 2 oxygens. But now I have 2 irons, so I'm going to add another iron. I have 2 irons. It is now balanced. So my formula is 2Fe plus O2 yields 2 FeO. Let's do another one. Nickel chloride plus sodium hydroxide yields nickel hydroxide and sodium chloride. Let's start with our metals. We have 1 nickel, 1 nickel, 1 sodium, 1 sodium. Things are looking good. 2 chlorines, only 1 chlorine. Let's add another chlorine. Now I have 2 chlorines, but now I have 2 sodiums, and I only have 1 over here. So I add 2 sodiums. Now let's get to our oxygens. We have 2 oxygens, 2 oxygens, 2 hydrogens, 2 hydrogens. It is now balanced, and so my chemical formula is NiCl2 plus 2 NaOH yields NiOH2 plus NaCl. Right, let's continue with these. I have copper plus silver nitrate yields copper nitrate and silver. Let's start with our metals. 1 copper, 1 copper, 1 silver, 1 silver, 1 nitrogen, 2 nitrogens. So let's add another nitrogen. But now I have 2 silvers and only 1 silver. So let's add another silver. And now I have 1, 2, 3, 4, 5, 6 oxygens. 1, 2, 3, 4, 5, 6 oxygens. The formula is balanced. And my formula is now Cu plus 2AgNO3 yields CuNO3 plus 2Ag. Now let's continue with this. We have barium nitrate plus potassium sulfate yields barium sulfate and potassium nitrate. Start with the metals. 1 barium, 1 barium. 2 potassium, only 1 potassium. Let's add another potassium. Now I have 2 potassiums. I have 2 nitrates, 1 sulfur, 1 sulfur, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 oxygens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 oxygens. It is now balanced, and my formula is barium nitrate, BaNO3 plus K2SO4 yields BaSO4 plus 2 KNO3s. And one more. Iron plus copper sulfate yields iron sulfate and copper. Let's start with the metals. 1 iron, 1 iron, 1 copper, 1 copper, 1 sulfur, 1 sulfur, 1, 2, 3, 4 oxygens, 1, 2, 3, 4 oxygens. It's already balanced, and so there is my formula. When you're balancing chemical equations, you're going to need to do a couple of things. 1, use a pencil. 2, get a big eraser because you're going to do a lot of erasing when you're balancing equations. That's just normal. It happens to everybody. The other is that when you add numbers, notice we only added the coefficient. We only added a number in front of a molecule. We did not change any of the subscript numbers. Those have to remain the same because if we change those, we change what that molecule is. We can only change how much we have of each. And we will always make sure that we have the same number of atoms of each element on either side of that arrow. We're going to be practicing more balancing chemical equations in class, and I can't wait to see you then.